Okay, so welcome to our class, and sorry that this is the first class for our optimization course. The idea of the course is 2105632. Okay, when you see any course starting from, you see that, of course, 2105, it's our department, right? And what about number six? Number six means, this course is for grad study, okay, for master or for doctoral students. And what should we start? We should start from ice breaking, okay? Ice breaking pitch. So I give you 1 minute for everyone. So each student will briefly introduce themselves by answering 4 questions. First, name, okay, and education, your background education, and work or research. Where you from? I mean, uh which laboratory, and your supervisor also. And the last one is the reason for being here. Okay, what do you want from this course? And okay, it can start from me. Oh, just wow, people keep joining. So all right, so okay, start from me. So I'm Surathep Kyohom. I got my PhD in chemical system engineering from the University of Tokyo, and that was 20 years ago. Yeah, no, more than 20 years, 22 years ago. And currently I'm working in Department of Chemical Engineering here at Chulalongkorn University, of course, focusing on energy storage system, in particular battery system. And I'm here because I want to share with you how optimization can be applied to chemical engineering problems from theory to practice, and to help you develop tools that can be useful in your research and careers. Okay, so who should be next? Jeremy?
Sure,
Okay.
sure, Ajan.
Yeah, turn
Uh,
camera,
okay.
then yes.
Yes. Okay. Good afternoon, everyone. Good afternoon, Ajan. My name is Jeremy. I graduated from Institut Teknologi Bandung or Bandung Institute of Technology (ITB) from Indonesia, with my bachelor's degree in chemical engineering. And currently, I am working with Ajan Suratep from the energy storage research, and I hope to have a deeper research in zinc battery actually for the specific topic. And the reason for being here is I want to understand the technicalities of optimization because we understand optimization in general, how to like achieve the best value for one process parameter, for example, with several constraints. But I want to dig deeper on the calculation and the real analysis actually. And I expect that to be very helpful for my research as well. Thank you, Ajern, and thank you, everyone.
Okay, thank you very much. We move to the next one. ชิดชนกครับ
Hello.
Yes. Yeah,
Uh,
can you turn on your camera? Open your camera.
okay. You
Okay, good.
okay. Hello, teacher. My name is Shichinok Minro. You call me Natty. I'm graduate from Material Engineer, Kesesat University. So today I am working with Professor Supaler in the catalyst lab group. I'm here because I want to learn more about advanced research technique. Okay. Thank you.
Okay.
Yeah.
Okay, thank you. Then we move to จารุกันครับ เปิดกล้องได้ไหม Yeah can you turn up open your camera Okay
My name is Jarikan Household. My nickname is Nampan. I graduated from physics, material science, and engineering from Kham Kiat University. Currently, I am working with Ajan Surathep. I am here because to learn more about battery. Thank you.
Okay so we move to the next one just one moment who will be the next one well Ken it's quite difficult for me เมธิชัยครับ
Okay, can you hear me?
Yes clearly yeah What happened internet problem Oh okay we move to the other one first and then we will come back เมธิชัย do you have problem
Sorry, my network
Okay
is
Okay yeah
have a problem. Okay, can you hear me?
yes
Okay, my name is Merichai Pachanupat. My nickname is Om. I'm graduated from chemical engineering at Binop Songkhla University. I am currently working with Professor Dr. Supalit Prasatham, and I am here because I want to know about optimization to use for thesis. Thank you.
Okay thank you then we move to the next one ธนวัฒน์ครับ
Hello, everyone. You can hear me?
Yes
I'm Thanapisar. My nickname is P. I'm graduate from KMN Palayak University. Professor is Dr. Surathep. The control lab. I expect to be able to better apply this knowledge towards experiment. Thank you.
Okay so we move to the next one Esla Jacker you are mute unmute yourself first
Okay.
yes
Good afternoon. My name is Esra Jagu. I graduated from Federal University of Technology in Nigeria, and my bachelor's is in chemical engineering. And currently, I'm working with Professor Salida, and I'm here to improve my knowledge about optimization.
Okay you are master student right master or PhD
Master.
Okay good we
Thank
move to the next one Prince Owusu
Okay, my name is Prince Owusu. I graduated from the University of Education in Ghana. I major in integrated science and minor in chemistry. I'm currently working under Professor Sarawut
Okay
in polymer science, polymer engineering. I'm here to learn more about optimization and its application in chemical engineering processes.
Okay good so we move to the next one ศิรภพครับ
Hello everyone, my name is Sirapop Dalit. I graduated from Chulalongkorn University at the chemical engineering. I currently work with Ajahn Gitchat Mongwailit at particle lab. Reason for being here. I'm here because I think this subject will be useful for my research. Thank you.
Okay, good. We move to the next one. ปิงครับปิง
Okay. My name is Ping Pierit, and from my education, I graduated from here from the Department of Chemical Engineering in Chulalongkorn University, and currently I am working with Ajahn Chung Chai to study how to use the carbon material in in solar cell application. And the reason I am being here, I'm here because of even though my research is mostly focusing on like the material science, but I study master in chemical engineering, so I want to study something more engineering. So I choose to study the optimization. Okay.
Okay. Wow. Next one ขวัญณภัทรครับ
Can you hear me?
Yes, clearly.
My name is Khwanapat Phongnarin, and you can call me Khwan. I'm graduate from Chemical Engineering, Mahidol University in bachelor degree, and currently I'm working with Ajahn Supalerk in catalytic laboratory, and I'm here in this class because I want to know more deeply in optimization and how to apply it. ค่ะ
Okay, good. มาใครอ่ะ มาเดี๋ยวนะ Your name is quite long มารุ
มารุเชษฐ์ครับมารุเชษฐ์
มารุเชษฐ์ Okay, yes.
โอเค
มารุเชษฐ์นะ Yes, because you put your ID in front, so
อ๋อ
yeah,
sorry ครับ
it's too long, yeah. Okay, yes, you can start now.
Okay, my name is Marushet Thongthep Pailot. I graduated from SIAT Chemical Engineering. Now I am with Ajahn Nitlung Tiwa. I am working. My project is to reach the carbon neutrality. I am here for like I want to know how to make a better decision making on things based on mathematics. So I chose optimization ครับ
Okay, thank you. Yes. And next one, Teba. Yes.
Can you hear me?
Yes. Yes, I can
Hello.
hear you.
My
Yes.
name is Sekas and I am from Pakistan and I have done my bachelor's degree from Sarkar University in PhD chemistry and currently I am working with John Plum and the reason why I am here is higher academic standards of the children and I want to learn about chemical engineering process. Thank you so much.
Okay. Though we cannot hear you clearly, but it's okay. Yeah, we can capture some information from you. Okay. สศิพักครับ
Okay ค่ะ Can you hear me คะ
Yes, yes.
Okay, my name is Sasipak Lamduan. I graduated from SIT Thammasat University in the field of chemical engineering. And currently I am working with Ajahn Athiwan Chotiprip about the research is about the extraction of the microalgae. So the reason why I am here because I want to know about the optimization process that can be useful for my research ค่ะ Thank you.
Okay. Okay, thank you. สุธรรมครับ
ฮัลโหลครับได้ยินหรือเปล่าครับ
Yes, I can hear you. All right.
Good
Yes.
afternoon, everyone. I'm Sutham Yamtak. I'm graduate from Khon Kaen University in the field of material of science, and currently I'm working with Ajahn Surathep. So I choose this subject because I've sent some message to Ajahn Surathep. I want to know some basics of coding, and he told me to assign this subject. Thank you.
Okay. Okay, good. Well, it's good that, well, you did not say that I forced you to register. All right. นัทสิทธิ์ครับ
Hello, my name is Nadasit Tensi. I graduated from Chemical Engineering, Chulalongkorn University. I am working with Professor Tuk in control lab. I am here because I want to have a better understanding in optimization of chemical process.
Okay, thank you. And who else? ปัญชนกปิงศิรภพ Prince Esla ธนวัฒน์มิตรชัยชรุกันชิดชนกนิติพลนะนิติพล right
Nitiporn. My name is Nitiporn. Good
นิติ
morning,
พร or นิติพล
Nitiporn.
นิติพร okay
Okay. Good afternoon, everyone. My name is Nitiporn Chambushana. I am graduated from Chemical Engineering, Chulalongkorn University. Currently I am working with Professor Shalathep Usaku in Biochemical Engineering lab. So I am here in master degree because I want to work on biochemical engineering project. And that because of I passionate about BCG economy.
อือฮึโอเคศักดิ์ภูมิครับ เปิดกล้องหน่อยอย่า
Okay. Hello. My name is Ben. I graduated from Chulalongkorn University with a bachelor degree in chemical engineering. Currently, I am working with Ajahn Paisan research group on advanced control, and I'm here because I would like to gain more knowledge in advanced process control to optimize the process for my research.
Okay, good. So last time we met in advanced math, right? Advanced mathematics.
Yeah.
Yes. But you withdraw it
Yeah.
after my session. Okay, good. All right, so well, thank you everyone. So now we know each other, right? So now it's time for optimization. So well, what we will cover in this course, okay? In this course, we will cover the basic and advanced concept of optimization and different types of mathematical programming and convex, non-convex programming and global optimization. That is briefly, I mean, wow, it's in a simple words. But when we say mathematical programming, what does it mean? What does it mean about mathematical programming? This one, just one moment. Let me draw. Yes. This word, mathematical programming. What is the difference between mathematical programming and computer programming, let's say? Any idea? Jeremy, can you tell us?
Yes,
What do you think?
Ajahn.
Yes, what do you think about mathematical programming? What does it mean? What do you
I
understand
think
about it?
for mathematical programming, it is actually like computer programming, but it is focusing like writing mathematical equations, algorithms, specifically to solve maybe like multivariable equation, something like that. I believe.
Okay, I will tell you later about the mathematical programming, but it's wow, it's totally different from computer programming. Okay, it's not an instruction. A computer code is not computer code at all. It's a kind of formulation of problem. Okay. In particular, it is optimization problem. We formulate anything into optimization problem, and we write optimization in a certain form. Okay, and we call it mathematical programming. Okay. And the next one, convex and non-convex concept. For this convex and non-convex, we will deal with them. I mean, for both convex and non-convex later. Okay, you know the difference between linear and non-linear, right? It's quite simple. It's straightforward, I believe. In a linear form is a one type of convex, okay, convex programming. But we also have several types of convex, okay, not only linear, okay. But what about non-convex? Non-convex is not convex, all right? Convex is well, if we look at the form, if we have any function where, well, circle is also a form of convex, okay. Well, we will deal with them later, okay. But just to let you know that we have this concept, okay. And okay, so what is the optimization problem? Optimization is the, well, it's written here. It's a process of finding the best solution within some constraint. So we don't focus on the minimum or maximum, okay? But we also consider the constraint. For example, well, we allow to move a variable in a certain range. That is our constraint, okay? Or the variable must satisfy something, some criteria, that is constraint, okay? So we consider both minimum, maximum, and constraint at the same time, okay? So this is kind of mathematical tools, okay? So when we talk about optimization, you cannot avoid using mathematics, okay? And imagination. Yeah, and it is, I told you that it is a mathematical tool. And this is a mathematical tools for decision making, okay? And it can be used and can be applied in various fields, okay? And we also, in this course, we also introduce the idea of function to be minimized or to be maximized, and explain why optimization is useful in real world scenario. Why do we use optimization? Why the optimization is important? I mentioned to you that optimization is a mathematical tool, right? But what is the connection between those optimization tools and real world problem? In real world, every day, in daily life, you have to decide, okay? You have to make a decision on several things, okay? And you cannot avoid that, right? And well, for example, you just had lunch, right? When you had, well, every day you have lunch, of course, in the canteen, maybe, yeah. And you have multiple choice. You have various choice. So you have to decide, right? You have to make decision what to eat today. Okay. Wow. And this is a process of optimization also, because it's you have to make a decision, right? What to eat. Okay. For example, not always you consider only the flavor, right? For example, if you have only 30 minutes and you have to have lunch, so the important thing for you maybe, well, which one has a shortest line, okay? That means it is the fastest one, right? Because you don't have time, or you don't have much money today on that day, okay? So in that case, you have criteria on the available cash in your pocket, okay? So that is a constraint you cannot break, right? So you have to find the best choice. I mean, you have to make decision on that, right? Minimize your objective. I don't know what your objective is. Maybe the time, the fastest one, or delicious one. I don't know. Yeah. And also you have constraint, multiple constraint, okay? Or you have to buy, for example, smartphone, and you have a list all the available smartphone in the market at that time, right? And of course, each one has different price, right? And you have to consider that, right? Also, you have to consider function. So this is a process optimization also, okay? Okay, so what is the importance of the optimization? Okay, optimization can be a game changer when it comes to efficient use of resource. You have a limited resource, or you want to minimize your cost. Of course, you require optimization, right? Or maximize your profit maximization. Again, you have to make decision on that. So you need optimization, okay? What else? Can you raise more example of the optimization? What you want to do to make a decision? Sirapop ครับ Sirapop
Yes.
Yes, can you raise some example?
Uh, um, now we have to consider about the environmental impact. So sometimes we do use the optimization to minimize the pollution that we release from the factory.
Yeah, that is possible. Yeah, it depends. Okay, that is more. Wow, it's more engineering that in that sense. Okay, but I mean, well, even not engineering in daily life, you also need the optimization. Yeah. All right, so we will explore the important optimization, including various real-world example, and I will show you how optimization can be used, maybe in supply chain management, in production, in energy system, and in chemical processes. Okay, so let us use some example. I mean, it's real world problem, of course, but it's not engineering problem. For example, if you want to go to the Grand Palace, you know the Grand Palace, right? From Chulalongkorn University. This is the optimization problem because you have to make decision, right? Can you explain this process? ขวัญณภัทรครับ
Yeah.
Yes. Can you explain this process?
To choose the fastest way to Grand Palace.
Yes.
First we have to think like which transport we can go, like from MRT, BTS, from boat or bus. There are many ways to go. So
Yes. And you see that it is an optimization problem, right? You have objective. It depends on, you choose the objective. The time used for travel or the cost you have to spend, okay? It means, fastest way or cheapest way, right? And the rest will be your constraint. For example, if you need a cheapest way, of course you have a limited budget for that transportation, right? For the transportation, then these things can be your constraint, okay? Or the number of interchange, how many times you have to change the mode of transportation, something like that, okay? Or I'm not sure you do a shopping, yeah, for your family or not, okay? if, well, how many times you do shopping in a week? สถิพักครับ
Huh.
You do shopping by yourself? Or supermarket?
Yes, sometimes.
Okay. How many times you do in a week?
I think once a week.
Once a week. That's good.
Yes.
Yes. So normally you have a list of items you want to buy.
Yes.
Okay. And you have a limited budget or you have unlimited budget?
I have a limited budget.
Yes. And also, well, you have choice, right? In supermarket, well, you have, for example, if you buy detergent, you have multiple choices. You have a vast number of brands for detergent, right? And each brand, of course, it has different price. Okay. And
Yes.
then you have to optimize which one you want to buy. Okay. All right.
Yes.
And this is also optimization problem. Okay. And this will your decision making. Okay. Thank you. Now you see the importance of it, right? Now, while we move to something more engineering, close to our field of study, it's related to chemical process. Okay, if you work in a chemical process and you are asked to design a new process to do something, okay, maybe a reaction process, the part, reaction part or separation part, it depends. Okay, and if the process doesn't exist at all, you are asked to design a new one. You have full of degree of freedom. So you have design parameters, various design parameters, right? It's all degree of freedom. Okay. You have to set some objective, right? Your objective may be about the process which can, what's it? The capacity of process in certain value. And what else? I don't know. Yeah, you list everything. Some of them be your objective, okay? But the rest becomes the constraint, okay? Or if the process already there, okay? Let's say we bought in process that already exists, okay? And you are asked to operate it. You cannot change the design parameter, right? The design parameter already fixed. And what to produce and how much, how large, okay, we can produce from it. This is also optimization problem, but the degree freedom is smaller. The number of degree of freedom is smaller than the first case where we have to design the design parameter also. But this one, you are allowed to adjust what can be adjusted, okay? Only the operating condition and what to produce, something like that. But both of them, we need optimization tools. Okay, so now I have a activity, group activity. Okay, so how many? Well, we have 17 person. I will break you. I think 6 group is enough. Okay, and each group you will discuss among yourself first. Okay, I will give you 15 minutes to discuss among yourself. Of course, I will break the room, and we have 3 problem sets. You can capture your screen. Okay, problem 1 is fruit basket optimization. Okay, you have 100 baht to buy apples. Okay, 2 baht each, and bananas 5 baht each. Okay, don't pay attention to the cost. Maybe the cost is not that. Yeah, and you must buy at least one of each. Okay, what combination maximize the number of fruits? Okay, and the next problem is we have 3 problems. The next problem is you have to design the shortest route. Okay, you need to visit point A, point B, and point F. Okay, you start from point A. And travel time, you can see the travel time between each node in this graph. Okay, you find the shortest route that cover all points and return to A. All points mean point A, point B, and point F, and you return to A. Okay, the shortest route. The shortest mean well because this is the distance. Let's say this one is the distance between A and B is 4 unit of distance. Okay, from B to D is a 10 unit of distance. Okay, and problem 3, mixing liquid. You want to make 1 liter of a mixture from 2 liquids. Liquid X, it costs 10 baht per liter. The quality is 80. Liquid Y costs 6 baht per liter. The quality is 60. You need a mixture of quality above 70. And what proportions minimize the cost? Okay. So we have 3 problems, and we form a group. Okay, and each group you discuss only I will assign the problem. You work on only on one problem. Okay. How to make a group? Just one moment. I have to. Yes, we create breakout room for 6 room. And I assign automatically in this 6 breakout room. Okay. Okay, good. Oh, once you will spend 15 minutes on the problem, 15 minutes, okay? And after that, you have to present in 1 or 2 minutes about your solution, okay? The methodology. I want to know the chain of thought. Yeah.นัทสิทธิ์ครับนัทสิทธิ์ไม่ได้เข้าในกลุ่มอ่ะ Okay. So Okay, so welcome back. Okay, welcome back. So I believe everyone finished, right? Finish your pitch already, right? Okay, so we start from the first group. Hmm? Who will be the representative of the first group? Group 1.
Okay, for the problem 1, right?
No, not problem 1. Group 1, Group 1. Group 1, of course. Group 1 is problem 1, but Group 1, there are 2 groups, right? There are 2 groups for problem 1. Group 1. Maruchet, Esla, or Sakumi ครับ
Okay ครับ it will be
Yes.
me then. So
Yes.
we got the question that are for to find the maximum number of fruit of the combination of apple and banana. So I can type in the equation, right?
Yeah, you can present
All right. So
your strategy. Yeah.
So our strategy that in order to get the maximum number of the fruit, but we need to buy at least one of each. So the banana we will buy only one banana because it had a higher cost compared to the apple. So we can like create a equation for these. It is 2x plus 5y equal to 100. So x is apples and y is banana. So as I said, banana has a higher cost than apple, so we gonna buy only one bananas, and we plug in the number, so we get we need to buy like 47.5 apple, but we cannot buy the half of the apple, so it's gonna be 47. So the total is, wait, let me check that. So
It's
the total
okay.
we buy is 48 fruit cup. So
Okay.
is this
It's okay. It's okay. We don't need a exact solution, just the idea. Okay.
all right? This is the idea.
Thank you. Yes, thank you very much. So we move to the next group. Charukan, Jeremy, or Thanawat. Yes, one of you present the strategy for problem 2. Charukan, Jeremy, or Thanawat. Right? You are same group, right?
Yes.
Yes.
We can we show the screen?
Yes, you want to share, right?
Yes.
Yes, you can share. Can you share it?
Uh-huh.
Yes, okay.
Can you see this? We
Okay.
think A to B and B to D and D to F can go A, B, and F, and we will return the line F to D and D to E, E to C, and C to A. It is the shortest line. ครับ
Yes, but what about strategy? The solution is not so important as a strategy. How do you come up with that solution?
Solution.
Okay, I will try to help slightly, if I may. For the strategy. First, from point A until point F, there is one path that is quite unavoidable, that is D to F, because in order to reach point F, we need to pass through point D. We cannot use point E. So that is kind of fixed. So now it is only a matter of traveling from point A to point D, and we have plenty of options like from ABD, ACBD, ACED. And we found that the shortest route is ACED because it gives a total time of 9 minutes. But with the constraint that we need to pass point B at least once, the first route we will pass through point B, but the returning route we don't need to pass point B anymore because the first constraint has been fulfilled.
Okay. Okay. Thank you. Thank you. Then we move to the next group. The next group, wow, working on problem 3, Chichanok, Prince Owusu, or Sirapop.
Okay. For problem 3, they have to mix the liquid and to minimize the cost we use. So first, we have to mix liquid X and Y and mix it in, make it 1 liter. And finally, is that's it the equation. That's
Okay, you develop the equation, right?
yes.
Yeah, so that equation represent, can you tell us again about what that equation represent?
First, we have the positive function to minimize cost of it. We have is the proportion of mixture of liquid X multiplied by its cost. Multiplied by its quality. Multiplied with cost is the opposite function. Plus the proportion of liquid Y multiplied with its cost too. And then we have the constraint we need to consider is the quality of it. We have to make it that it higher than 70%. So we have another constraint of it. And
Okay.
finally, we have to mix it, and it must be 1 liter. So liquid X plus liquid Y should be equal to 1. This is another constraint.
Okay. Okay, thank you. Okay, so how about the other group? Well, we have 3 more groups, right? But I'm sorry that we ran out of time. So, let us skip on that and back to our main lecture. Okay. So you see that you have idea, right? You have idea on the strategy, but it's not, I think it's not unified yet because, several groups use different, I think different technique, though you try to map it to the equation, some equation, but it's still, I think it's still not clear yet. Okay, let me show you something. This is the structure of the optimization problem. Okay, you see that some of you try to write an equation to represent some part of this structure. So what do we have now? we have minimize, min here, or it depends. If you want to maximize, you can write max instead. Okay, min or max is okay, but let us use min. Okay, use minimize first, and below minimize, we have x here. This x is, we call it decision variables. Okay, what does it mean? This is the variable we want to know. Okay, you want to adjust all these things, all the x. Okay, you may have x, y, z, or x1, x2, x3. Well, it depends. No matter how many variables you have, if you can adjust it, and if they are independent, you can put it here, and we call them as decision variables. Okay, remember decision variable, because throughout this course you will be familiar, you will hear that decision variables again and again. Okay, all right. Decision variable, it's something, it's variable, they are variables, they're something that we can adjust, and they are independent. Okay, and fx, this fx, we call it as objective function. Okay, this is the function we want to achieve. We want to minimize fx by adjusting x. Okay, by adjusting decision variables, we want to achieve the minimal of fx. Okay, in case of maximum, of course, it is maximize fx means, well, you want to maximize your objective function. Okay, and what else do we have in this structure? We have this variable right here. Okay, we write st. What is standing for st? St is an abbreviation of subject to. Okay, we want to achieve minimum of fx by adjusting x, and at the same time, it's these decision variables must meet these criteria, subject to these criteria. Okay, and there are two types of criteria we have, of constraint we have. The first one we call inequality constraint. Okay, inequality constraint means, well, you can choose any x, any decision variable, as long as those inequality constraint g function is greater than or equal 0. Okay, sometimes it's not 0 at the right hand side, but no problem, we move those constant to the left hand side, and then the right hand side becomes 0, right? Okay, this is the standard form. And we have another types of constraint, we call it equality constraint. And for this equality constraint, we find the decision variable, our x, to satisfy this equation. Okay, hx equals 0. Okay, and we treat equality constraint and inequality constraint differently. Okay, in a different way. So we have to separate those constraints. Okay. Okay, so the optimization problem consists of objective function and constraint. Okay, and those constraints can be equalities or inequalities. Okay, some optimization problem doesn't have constraint at all, or they can only involve equality constraint or inequality constraint only without equality constraint. Okay, but all optimization problem needs decision variable and objective function. Okay, you cannot have optimization without objective function. Okay, without decision variables. Okay, any questions? if you look at this structure of optimization problem, you can see some similarity between system of equations and this optimization problem. Can you notice something? If we have many equality constraints, okay, and if this number of decision variables equal the number of equality constraints, what does it mean? Our problem renders to system of equation already, okay? That means we cannot adjust anything because all the decision variables are already defined by equality constraint, okay? So we have to think about the degree of freedom first. Once you formulate the optimization problem, you have to think about, you have to check the degree of freedom, okay? What is the degree of freedom? You can, for physical meaning of degree of freedom means, well, how many variables, independent variables you can adjust, okay? How many decision variables that, well, you can freely adjust it, okay? Adjust them, okay? All right. So if the degree of freedom is 0, what does it mean? Degree of freedom is 0. That means, well, everything already defined, okay? You cannot adjust anything. That means the system is equation, okay? System of equation is not optimization problem, okay? But for our case, for optimization problem, we consider only the case where degree of freedom is greater than 1, okay? That means, well, you still have room to adjust, right? You still have some free variable to adjust in order to achieve minimum F or maximum F. It depends, okay? What about degree of freedom less than 1? If the number of degree of freedom is negative or less than, no, not less than 1, less than 0 is negative. So that means the number of relationship is greater than the number of free variables, okay? You have conditions more than the number of decision variable that you can freely adjust. For example, in this graph, you see we have x1 and x2, right? Or x and y, depends, okay? In this case, if we want to satisfy both f1, f2, and f3, I mean, all these f1, f2, and f3 are equality constraints. That means we need a point that can satisfy f1 and at the same time satisfy f2 and at the same time satisfy f3. You cannot have such a point, right? For example, this one. What about this point? This point, of course, satisfy f1 and f3, but not f2, right? This point, satisfy f2 and f3, but not f1. Or this point is satisfy f1 and f2, but not f3. All right? So this is a case of negative degree of freedom. Okay? And of course, it is the worst case because we cannot satisfy the condition we have. What about degree of freedom is 0? If degree of freedom is 0, it's not optimization problem anymore because it's already defined. It is system of equation, okay? For example, in this case, we have two conditions, F1 and F2, okay? Both are our equality constraint. So we have two decision variable, x1 and x2. So the solution is here. You don't have to solve the optimization problem. Instead, you solve the system of equation, right? You find this intersection, and this is the solution. Okay, what about optimization case? In case of optimization problem, we have degree of freedom greater than 0. Okay, it's positive degree of freedom. So the number of relationship is less than the number of free variable. What does it mean? It means that, of course, you have equality constraint. You have multiple points, right? Multiple solution that can satisfy your equality constraint F1, right? You have infinity point here, okay? And among these points, you need one point that satisfies your objective function, minimum or maximum, okay? Okay, so any questions? You have any questions regarding the structure of optimization problem? And this is we call the mathematical programming, okay? So your task at this point is you have to map between real world problem or for example, the problem I gave you as a case for your previous activity, okay? Map those things to this structure, okay? And we call it mathematical programming, of course. And if you write, you translate, you interpret your problem into this form, and then you can solve using several algorithms, optimization algorithm available in the market. Okay, any questions? No? Okay, so we move to the next things. Okay, so we try to classify the optimization problem. Okay, for the classification of the optimization problem, we can separate them, we classify them using different property. Okay, we can classify based on the existence of constraint in the optimization problem. If your optimization problem contain constraint, involve constraint, we call it constraint optimization problem. Okay, and if it's not, we call it unconstrained optimization problem. Okay, you divide it to unconstrained and constrained optimization problem. Okay, we classify based on existing of the constraint. What do you think? Which one is easier to solve? If we deal with the same objective function, constraint or unconstrained problem, which one is easier to solve? Satipak, which one is easier to solve? Yes? You have two choices, only two choices. Constraint or unconstrained.
In my opinion, I
Yeah.
think constraint.
Is easier or more difficult?
Oh, I think constraint it's difficult than unconstrained.
Yes, right. Most of the case, yes, most of the case, constraint is more difficult, okay, more complex to deal. And the next thing is, we can classify the optimization problem based on the nature of the design variables. Remember, we have design variables, right? And if we look at the domain of the design variable, if the domain of our design variables are integer, we call it integer programming. Okay. For example, the first case that you buy the banana, right? Banana and apple. You cannot buy half, right? You have to buy one banana, two bananas, one apple, two apples. You cannot buy 0.5, 0.3, 0.35, 0.34, something like that. So we call it integer programming in that case. Okay, but instead, the third problem where we deal with the liquid mixture, in that case, of course, you can take 0.3 liter, 0.35 liter, 0.4 liter, something like that, right? Okay, that's a real variable, right? Okay, yeah, it's not integer. Okay, so that it's, well, we classify the optimization problem based on the nature of decision variables. Okay, and which one is easier to solve? What do you think? นัทสิทธิ์ครับ นัทสิทธิ์ are you here?
Yes.
Yes, which one is easier to solve?
Mm.
Hmm?
I think um uh structure.
No, you have two choices between integer programming, okay, and non-integer programming.
Oh, I think
Which one is more difficult?
non-integer.
Okay. Yeah, sorry to say that. Most of the time, integer programming it's more difficult, okay, because it can take only integer number, right? So that is the difficult part, right?
Okay.
Yeah. Okay, so what else? Oh, we can classify based on the nature of this variable, based on different things like, well, the variables can take, it's a parametric or static. Yeah, this one also. Yeah, totally different thing. For example, parameter. For example, the price of the, you remember the third case where we have the quality or the price of each liquid, right? Whether that constant is a parameter or not. If the constant is a parameter, we call it parametric optimization problem. And we have a solution, which is a function of that parameter. Okay, we try to solve, and our solution obtained is a function of that parameter. Okay, and for static optimization problem, it's like that way that, well, all the constants, it's fixed. Okay, the parameters, it's not parameter, it's fixed, it's a constant. So it's a static optimization problem. Okay, so what else? We can classify based on the physical structure of the problem. It can be optimal control problem. For optimal control problem, well, it involves the dynamic of some function. For example, your constraint can be a function depends on time. For example, in case of a control problem where you adjust the manipulated variable and you track the control variable at each time, right? Each sampling time, and you want to control, you want a particular the behavior of that dynamic. Okay. So in that case, we call the problem as an optimal control problem because our solution is a profile of these variables, and we track a profile of our objective function and also profile of our constraint, something like that. Okay, so in other words, we call this type of problem as a dynamic programming. Okay, because the variables are dynamic. Okay, so we We also have non-optimal control problem. Okay, this is opposite to optimal control problem. Okay, and what else? We can classify the optimization problem based on the nature of equations involved. We look at the constraint and also objective function. If all constraints and objective functions are linear functions, we call it linear programming. Okay, this is the simplest one to solve. Okay, if we say linear programming problem, that means the constraint also linear, the objective function also linear function. Okay, I believe that I don't have to explain the linear function, right? Everyone knows the linear function, right? Okay, and if not linear, no matter the objective function or constraint, any of them nonlinear function, we call the problem as nonlinear programming problem. Okay, this is a broadly classification. Okay, we also have geometric programming problem, and if anyone interested in geometric programming problem, you can look in a book. Okay, in our textbook. Or quadratic programming problem also, yeah, you can guess from the name quadratic. What does it mean? Quadratic is a quadratic function. So the objective function must be quadratic function. So we call it quadratic programming. Okay. And what else? We can classify the optimization based on the permissible value of desired variable R. I explained this already. It's a real value programming problem and integer programming problems. Okay, I should explain it here, but I explained it before. All right. Also, we can classify the optimization problem based on the deterministic nature of the variable. I explained previously about parametric optimization problem where the constant it's not constant. Some parameter is not constant. It's a function, right? It's a kind of parameter. But in this case, deterministic, it's similar to what we explained before, where all the values are constant. But for stochastic programming, it means that some parameter, some value is not deterministic. It's a kind of probabilistic or stochastic. What does it mean? For example, in case of the first case where we consider the fruit, right? We consider buying a fruit. And in that case study, in that problem, the price, the cost for bananas and apples are fixed. But if the price is not fixed, okay, the price are float. What does it mean? It can be previously banana is 5 baht, right? It can be 5.1, 5.2 baht for decreasing or increasing. In that case, if we know the distribution or probabilistic distribution of the price, then we can apply it into optimization problem, and we call that problem as a stochastic programming problem. Okay, I can read some other example. For example, if you want to open a book, what else? What can be a good try? You want to open a petrol station, okay? And your task is you have to order the petrol, okay? And once you order the petrol, of course, you sell to your customer, right? But you know, the price of the petrol or your cost, okay, your order, the price of your order vary, okay? It can be fluctuate, okay? So you have to optimize when and how many and how much petrol you have to order, okay? When the price is fluctuate, okay? That is when you formulate the optimization problem, you see that the price is not the fixed price, but it can take any value from the distribution, okay? You know, the price fluctuate and it can be vary in some range, even small range, okay? And then once you formulate your optimization problem, you take that value as a fluctuation, okay? Varying value. Okay, so the next thing is classification based on separability of the function. The classification based on the number of objective function. This is interesting because, well, in our previous case, we consider only one objective at a time, okay? We formulate optimization by using only one objective. We adjust the decision variable in order to achieve minimum or maximum of certain single objective function, okay? But in real world, sometimes you have too many objectives, okay? For example, you have two objectives. You want to minimize one thing and you want to minimize other thing at the same time. That called multiple objective. And unfortunately, those two objective functions are conflict. You try to minimize one thing, but instead the other objective function is increasing, something like that. So in that case, it is called multiple objective functions. Okay. Okay, this is a case of multiple objective function. We have two objectives, one objective, objective 1, objective 2. Okay, and you see that we want to minimize both. We want to minimize objective 1, so we want a solution in this direction based on objective 1, and we have to minimize object 2. That means well, we want to minimize. We want to go this direction for in your viewpoint of objective 2. Okay, but you see that the solution we have cannot satisfy both. Okay, for example, we cannot say this solution is better than this solution, right? Why? Because in a viewpoint of objective 1, of course, this one is better, right? Because it goes this way based on objective 1. But if we look at objective 2, you see that this solution is better than this solution, right? Because in objective 2, we want to minimize. This one is better, right? So we have multiple solutions where all these solutions are not dominated solution. Okay, we call it non-dominated solution. What does it mean? We cannot say this solution dominate this solution because it's non-dominated. In viewpoint of objective 1, this one is better. In viewpoint of objective 2, this one is better, right? In an extreme case, you can compare this solution and this solution. You see that this one in objective 1, this solution is better. Okay, but in a viewpoint of objective 2, this one is better than that, right? Okay. Any questions? Oh, I have a question in the chat that can you give us an example of static optimization? For static optimization, well, it's the problem you deal in your class activity, like while designing the number of fruit you buy, or well, the number of was it the amount of liquid mix liquid 1, liquid 2 to form a liquid mixture. That all those things are static optimization problem because all the variable inside, I mean all the constant inside is already fixed. It's already static. It's not stochastic. Okay. Okay, so I can give you more idea on the classification of the optimization problem. Okay, but before we go to the next slide, sorry, I will have a break for maybe 15 minutes, and if you have any question, you can ask me now. Okay, before we have break for 15 minutes. Anyone?
Ajahn, I want to ask
Yeah.
something. For the multivariable, multiple objective function
Yes.
type of optimization,
Yes.
whether it is in this class or in real world application, like is there
Mhm.
any method to actually determine one best solution, like maybe
All
in
right.
terms
All
of
right.
some equation like that?
Yeah. Normally, well, there are several strategy to find a to make a decision to find a single solution of it. But the best way is to find a non-dominated solution first. Okay. And in order to find non-dominated solution, we call it Pareto front. Pareto front. We have several techniques to or algorithm to find the Pareto front. Okay. I can give you some example of the algorithm later. But the good thing that of the method that we find the Pareto solution is we have multiple solution, right? And from this multiple solution, you can assign the weighting. Okay, you can form the weighting function. How do you weight this objective one, and how do you weight objective two? You can assign the weighting, and then you choose one solution which is best solution based on your weighting parameters. Okay, but some algorithm, you have to specify the weighting parameter before itself or find the solution. That one I don't encourage this one, that kind of algorithm, because you have to specify the weighting parameter before you solve the problem. Okay, which is of course, sometimes one problem is sometimes you don't know actually the weighting parameters. You don't have idea what about the size of the weighting parameters. Okay, but if you solve this non-dominated solution first, and then you see, right, you see the range of each parameter, and then you can find more information about the importance of each objective function, and then you can assign appropriate weighting parameters.
Okay, Ajahn. Thank
Okay.
you, Ajahn.
Any more questions before we have a break? Okay, then if no question, come back on 12:55. Okay, we have break and come back again in 55. Hello. Welcome back. Hello, everyone. Welcome back. Welcome back. Ready? Hmm?
ไหวอยู่ครับไหวยังอยู่ครับ
Okay, why you? Okay, so, well, we continue, okay? So, yeah, let me, well, show you several types of optimization problem, okay? Which is quite important in this case. So the first one is continuous versus discrete optimization, okay? If the optimization problems, I mean optimization variables or decision variables can take any values in a given range, can take real number, we call it continuous optimization problem, okay? If it can only take a, well, certain value, I mean integer or, well, or any, well, particular number, we call it discrete optimization problem, okay? It's discrete, it's not continuous. And the second item is deterministic versus stochastic optimization problem. Deterministic means that the data or data is known, okay, with certainty. But in case of stochastic optimization problem, some data is unknown, okay, or unpredictable, okay, or it's predictable but in a range, as a range, okay, as a, well, range, not fixed value, okay. The next one is convex versus non-convex optimization, okay. A convex optimization problem implies that the function is being optimized is a convex function, okay. Later we will deal with it, what is convex function and non-convex function, okay. But if all the function involved it's convex function, we call it convex optimization, okay. If it's not, we call it non-convex optimization problem, okay. And the next one is if we consider linear function instead of convex or non-convex, we consider linear or non-linear function. So if our objective function and all constraints are linear, we call it linear optimization problem, okay? If any of them are not linear, okay, are non-linear, we call it non-linear optimization problem, okay? That is very simple. Okay, so we have convex programming, okay? If our objective function is convex optimization problem, then we call it, the problem is convex programming, okay? So we need a convex set of function and convex optimization problem, okay? So what is convex function? What is convex function? Oh, it's not included here. Well, the convex function, it's, well, when can you rest some, do you have idea on the convex function or non-convex function? About convex function, have you ever heard this word before, convex function? Any one of you? มารุเชษฐ์ครับ มารุเชษฐ์
ครับผม
Yes. Do you know convex
So
function?
I'm not remember, if I not remember it correct, I think it's the line that goes through the critical point of the parabola thing.
No, I want something more general. Okay. It can
Okay.
be, well, apply on anything. I showed you something. Just one moment. This is nice. Let me stop the share first and then. Okay. One moment. Yeah. Okay, so you consider this. Yeah. this figure. On the left hand side, we call it convex function. Okay. But the right hand side is a concave. So you see the difference? What is the difference? This is this is the way we define the function. I mean, convex function and non-convex function. For the convex function, you see that the function always, if we take two points from this function, from the function, and we draw a line between these two functions, you see that always the value of the function always smaller than the value of on the line connecting between these two points. Okay, so we call it convex function. What about non-convex function? For non-convex function, if we take 2 points the same way, okay, and that, well, some points between that range, that the function has greater that value than the line connecting between that 2 points. We call it non-convex function. Okay, so you see that if we have a linear function, the linear function also, it's an extreme case already about the convex function. So in this case, if we can guarantee that our function, I mean the objective function, is a convex function, and the next thing is all the constraints form the convex set. Convex set is another story. I will tell you later, but the idea is similar thing, right? So we can use a convex programming, okay, the algorithm which is designed for convex programming to solve that problem. Okay. What about non-convex programming? For non-convex programming, of course, the objective function or the constraint, well, do not satisfy the convexity. And that's raise problem then, because you cannot use any algorithms designed for convex function called convex programming anymore. And this class of optimization problem is a non-convex optimization problems. Okay, and it's quite challenging compared with the convex programming. Okay, convex programming it's much easier. Okay, A very common convex programming includes linear programming, also quadratic programming. Both of them are convex programming. Okay, so what I introduced you, I introduced the mathematical programming, right? So about the formulation of the optimization problem. Okay, you have a standard form of optimization problem consisting of the objective function, decision variables, and list of all constraints. Okay, so I recommend you 3 things. Okay, the technique to solve the mathematical programming. Okay, starting from real world problem to the solution. Okay, because the formulation of the optimization problem is only a part of the process. Okay, once you interpret from real world problem into optimization problem, which is a mathematical form of the optimization problem, well, you have to solve the problem and obtain the solution. And once you obtain the solution, you have to test the solution with the real world problem, not the solution to the, well, abstract form of it. Abstract form is a kind of the optimization problem. Okay, so we need problem definition, strategy, and solution. Okay, and all these things are connected. Okay, from the first step, from real world problem, you have to formulate the optimization problem. Okay, this stage is, well, it's an interpretation from the real world problem into the mathematical form. Okay, so formulate the optimization problem include mathematical representation of the real world problem. And what we need accurate representation in an efficient form. We have 2 things to consider. The first one is accurate representation, and the second thing is it must be in efficient form. For example, if you have real world problem, which, well, it's of course it's nonlinear. Okay, the behavior is totally nonlinear. So in order to represent it in an accurate form, of course, you need a nonlinear function to represent the real world problem, right? But you have to trade off with the efficiency, okay? Because we need efficient form. Efficient form means, well, you need a mathematical form, a representation, which is easy to solve, okay? If it's too difficult to solve, we have problem, right? Okay, so you have to trade off between accurate representation and efficient form, okay? And the next one is modeling and solve the optimization problem. Once you obtain the optimization problems, of course, it represents the real world problem, and it must be in an efficient form, in a form that you can solve it. You have solver to solve it, okay? So you have to consider availability of your solver, of your algorithm, okay? And the next thing to consider is whether it is a tractable solution or not. What does it mean, tractable solution? Tractable solution means, well, you can solve it efficiently, okay, by using resource you have, and it can solve by the time you want. What does it mean? For example, in control problem, you have to implement the manipulated variable every minute, maybe, or even smaller than that, maybe in second. Every second, you have to manipulate. You need manipulated variables, okay, to adjust your process. But if you formulate that problem and it takes 30 minutes to solve the problem, it causes problem, right? Because you have to implement the solution in a minute, but you have to solve it in 30 minutes or half an hour. So it's not tractable, okay? That is definition of tractable. We have to consider. The next step is interpret the obtained solution. So you have to consider satisfaction of the obtained solution, whether that solution you obtain can be implemented to the real world problem, okay? And requirement of problem reformulation or not. What does it mean? Remember that the solution you obtain by solving the optimization only reflect the problem that you formulated. And in the step that you formulate from real world problem to the optimization problem, you abstract it, right? Because the real world, the behavior of the real world problem may be more complex. And you believe that you cannot solve it efficiently. So you have to simplify something. You have to assign some assumption. You have to make some assumption on it, right? So once you obtain the solution, you have to be sure that the solution can be implemented in real world problem, okay? Not only reflect the mathematical form of the optimization problem, because the mathematical form of the optimization problem is really the abstract of the problem, okay? It's not the real problem, okay? Okay, so what happened if the solution obtained cannot be implemented in the real world problem? You have to reformulate the optimization problem again and solve it again, okay, until you obtain new solution. And then you test the solution to the real world problem again. Okay, any questions? Any problem on these things? About the 3 steps of solving the optimization problem? Any questions? Hmm? ทิชนกครับ ทิชนกยังอยู่ไหม
ค่ะ
โอเค มีคำถามไหมครับ Any
เอ่อ
questions?
ไม่มีค่ะยังไม่มี
Okay, okay, good. So we move to the next thing. Now we going to formulate the objective function first. For the objective function, we can consider maximize profit. Okay, you want to maximize profits, right? Most of the time, or minimize cost. Okay, if you know that your income is quite insensitive to, is not sensitive to the decision variable, so in that case, you can only minimize the cost. Okay, but if the revenue and also the cost is sensitive, they are both sensitive to the decision variables, then maximize profit is a good way, right? Or maximize utility, maximize the turnover, depends, okay? Maximize return on investment. What else it can be? It can be maximize the net present value, minimize redundancy, maximize customer satisfaction, maximize probability of survival, maximize robustness of operating plan, okay? And remember that all the objective function you choose, you must write a function of this objective function, your objective function, as a function of these variables, okay? If the objective function you choose is not a function of this variable, well, it's you have big problem, okay? Okay, so you can choose all of this, right? Of course, if you have some good reason, you can formulate the objective function differently, okay? And well, most cases, you formulate the objective function as a single function, and we call it single objective function. Okay. Most of the objective function optimization problem contains only one objective function. Okay. And it is single function problem. Okay. And in some case, you need multiple objective function. We call it multiple and conflicting objective. Okay. So in that case, we minimize F1, F2, F3, depends how many objective function you want to consider. Okay. The next one is minimax objective function, where we try to minimize objective function by adjusting one set of variables, and at the same time we maximize the objective function by adjusting different set of the distant variables. Okay, this one we call minimax. Okay, and this is different. This one is different from multiple and conflicting objective function. Okay, when we say multiple objective function, we mean this multiple and conflicting objective function. Okay, but minimax is a special class of the optimization problem. Okay, later I will explain you. Okay, what is a minimax in real world. And the other thing is the ratio objective function. For example, this idea can be used to convert the multiple objective function. If you have two objective function, okay, it can be used to convert these two objective function to one single objective function. Okay, for example, in this case, if you want to minimize F1 and maximize F2 at the same time, you can consider minimize the ratio of F1 to F2. You see that? If we minimize this ratio, that means we try to minimize F1 and maximize F2 at the same time, right? Okay, and one special case is non-existent and non-optimizable objective function. Okay, in some case you formulate the optimization problem, but the objective function is non-optimizable. Okay, and the next one is defining constraint. Remember that in the standard form of the objective function of optimization problem, we have constraint, right? Equality and inequality constraint. We have several ways to deal with that constraint. Okay, if your problem involves the productive capacity constraint and processing capacity or manpower, in this case, it can impose the inequality constraint. Okay, most of the case it is inequality constraint. For example, productive capacity constraint. For example, our process can have a maximum capacity of 100 kilogram per day, something like that. That means, wow, the maximum capacity is 100 kilogram per day. However, we don't have to use the maximum capacity for the production, right? So our constraint can be the production must be lesser or equal 100 kilogram per day, something like that. Okay. Okay. So this can be the capacity can be your constraint. Okay. And most of the case it is inequality constraint. Okay. The next one is raw material availability. Raw material availability means, well, for example, you plan to operate your plant and you have raw material, okay? And you can use your raw material at most, for example, 100 kilogram per day. You can order something like that. That means, well, you cannot operate by using higher than that availability, right? And it imposes the constraint to your problem. Okay, and these raw material availabilities are equality or inequality constraint. What do you think? ชิดชนกครับ Do you think it's a equality constraint or inequality constraint?
Equality constraint.
It should be inequality constraint, right? You don't have to order the maximum raw material. Okay, as long as you, for example, you want to maximize profit, as long as the profit is maximized, you don't have to use the maximum raw material, right? Okay, the next thing is marketing demand and limitations. Okay, this is quite complex, but it imposes a constraint for sure. Marketing demands and limitation means, well, you have some requirement in order to satisfy the marketing demands and limitations. It depends on your contract, whether you have a contract with your customer or not. If you have contract with your customer that you have to, they order you, right? And you have to deliver your product to them at certain amount, at certain time. That is equality constraint for sure, right? If you have that contract. However, it can be inequality constraint if, well, the market size is, well, is quite large and you don't have to satisfy that. You're quite sure that anything you produce, you can sell it to the market because the market is large. In that case, the marketing demands and limitation, well, can be inequality constraint. Okay. Okay. So we move to the next one. The next one is material balance. Okay, or continuity constraint. Material balance means, well, not only material, but also energy and other things, right? Kinetics, thermodynamics, whatever it is, or the model. Material balance constraints, energy balance constraint, or continuity constraint. These constraints are equality constraint only, okay? You cannot negotiate with it, okay? Whatever you put into your process, you will get the same amount out, right? So this is the equality constraint, the principle of the equality constraint. The next one is quality stipulation. The quality stipulation can be your constraint. For example, if you produce ethanol, well, the customer, you know that your customer need ethanol with purity higher than 99.5 volume percent. That means you cannot sell it if your product has concentration lower than 99.5, right? But if you give them 99.6, they're happy, right? Or 99.7, they're happy, okay? Because they get free ethanol, okay? So you see that quality stipulation is a constraint, and it is inequality constraint for sure. You don't have to satisfy as a equality constraint, okay? Okay, the next one is hard and soft constraint. Sometimes you can treat some constraint as hard constraint and some constraint as soft constraint. It's quite useful for dynamic programming or multi-period optimization. The hard constraint means, well, this constraint is hard. It cannot be violated anytime. Okay, but for soft constraint, that means, well, this constraint can be violated, yeah, any, well, moment of your time consider, okay? But in total, maybe, well, you can violate it, but not always, well, only a snapshot. Okay, the next one is a chance constraint. Chance constraint means, well, you allow, because, well, we are dealing with stochastic nature of some variables. And the way we set constraint is, well, the probability that this constraint is violated, we set as a probability. Okay. For example, yeah, probability that this constraint, what we meet the constraint is 0.8, something like that. That means, well, 80% of the scenario we consider it's, well, we can satisfy the constraint, something like that. Okay. This is different way we set the constraint using the chance or probability. So the next one, how to build a good model. We consider how to build a good model. So, well, if we want to build a good model, the first one we have to consider is of understanding the model. Okay, you model the way that it's easier. It's very easy to understand. Okay, you read it again, you understand. Okay, you send your model to someone, you don't have to explain much because you write model in a way that it's very easy to understand. Okay. The second item is of detecting error in the model. Okay, you should write the model, your model, in a way that it's easy to detect if any error happen. Okay, and ease of computing solution. This one is a different way. You should write a model that it's easy to compute. For example, you have a choice to write a model as a linear function or nonlinear function. Preferably, you should write your model as a linear function, right? Okay, because it's easy for computing. And the next one is unit of measurement. Take care of the unit measurement. Don't mix between several units together, because later you will have problem about a conversion unit, or sometimes you don't convert it properly. Okay. Okay. The next thing, well, I will introduce you some software we will use in this class. The first one is Excel solver. This one is a surprising optimization tool. You can use it to solve linear function or even nonlinear function in some case. Okay. And it's come with Excel already. Okay. But there's a limitation on some type of problem that Excel solver cannot solve. For example, the mixed integer linear programming, this thing you cannot use Excel solver to solve it. Okay. But anyway, Excel solver is still a good tools. In order to extend the capability of the Excel solver, I recommend Open Solver. Okay, you can go to this website, opensolver.org. Okay, by using Open Solver, you can deal with, well, it works similar way as a Excel solver. Okay, and it's working in Excel also, right? You install this plugin. Okay, and it's extend the capability of the solver in Excel. It supports not only linear programming, but also you can use it to solve integer and mixed integer programming also. Okay, or even use CoinOR CBC solver, or, well, other sophisticated solver. Okay, the benefit of the open solver is it's faster than original one. I mean the Excel solver, and scalable for large problem. Okay, sometimes by using Excel solver, it's limited by some size, by a certain size of the problem, but this one is extend the size of the problem. Okay, and it's useful for teaching or prototyping. So, and advanced version also support nonlinear models also. Besides Excel, we will use Python. Okay, we will do optimization using Python. And for Python, I recommend to what was it called? It's a library. Okay, it's Python library. Okay, so I recommend two things: CVXPy and Pymo. But in this class, we will use Pymo. Okay, I will not use CVXPy. But if you want to use CVXPy, you can do it by yourself. Okay. And this is Pymo. You can have get some information from this website. Okay, and also download the library from this website. Okay. To use it, of course, you need Python first. You can use Python in Colab, in Google Colab. Okay, or you can install that Python in your own notebook. It's okay. Okay. But in this class, I think I will do it in Colab. Okay. In Colab, and then I can share you some files through Colab. Okay, so what is Pymo? Pymo is an open source, of course. It's an object-oriented algebraic modeling language in Python. When we say to formulate the optimization, you define the objective function. You define the constraint and decision variable. You can solve it directly without writing the solver by yourself, the algorithm by yourself. You define the objective function using a certain form of defined in the library, and also add each constraint in the form of the Pymo language. And then Pymo will handle all the interface with the algorithm as the solver by itself. Okay. Okay. So, and the next thing I will use in this class is Gurobi optimization. Gurobi, it's a kind of a solver itself. It's not the what's it? It's not the modeling language. In case of Pymo is only modeling language. Okay, but it's used in Python. Okay, but for Gurobi optimization, Gurobi is a solver. You download it from here. It's a commercial software. Okay, so but you can download and use for free. Okay, for 1 year. Okay, but when you register, you have to use the email, July email. Okay, because it will check your email if you're academic or not. Okay, then you will request for academic license. Okay, and it allow you to use for 1 year. Don't worry about next year, because once the license is expired, you can request for another year. Okay, you can extend it as long as you use July email. Okay, so for Gurobi, Gurobi is one of the most powerful commercial optimization solver. Okay, I recommend this one. Okay, so we have a class activity again. Okay, so you look at the first example. Okay, you can download this problem in the slide I gave in my course view. Okay, there are 2 pages. Sorry, 2 pages for this problem. Okay, I will assign you. I will make 6 group again. Okay, and then you work as a group to identify the objective function and also constraint. Okay, try to do it by yourself. Okay, I give you maybe 15 minutes. Okay, Just one moment. Any questions? Okay, so our group will work. Well, room 6, no one in room 6 anymore, so it's okay. Now 5 room, or I recreated this. Oh, sorry. Okay, only 4 room. Just one moment. And oh, sorry. Okay, so we have 5 room. Each room will get the same problem here. Okay, you can access to this problem, right? You have 15 minutes to discuss among your group.
จารย์ครับผมหลุดมาจากห้องนะครับ
ห้องไหนอะห้องไหน
ห้อง6มั้งครับ
ห้อง6ใช่ไหมเดี๋ยว
ใช่ครับ อาจารย์ผมขอถาม objective อีกรอบหนึ่งนะครับ คืออาจารย์ให้หาคำตอบของ example เหรอครับ
ไม่ใช่ ไม่ได้หาคำตอบครับให้แค่อะไรอ่ะหาไอ้ตั้ง decision variable ตั้ง objective function ตั้ง constraint ขึ้นมาครับ
อ๋อ
อือ
โอ
ฮึ
เคครับ ได้ครับ
ครับ เดี๋ยวนะจันคิดก่อนเอาเข้าไปยังไงวะ assign เราเข้าไปยังไงเนี่ยมีใครอยู่ในห้องนั้นบ้างนะครับ
มีคนชื่อ
จำชื่อได้ไหม
Prince อะไรสักอย่างหนึ่งที่เป็นคนต่างชาติ
อ๋อ
เป็น
โอเค
Prince
โอเคโอเค
โอเคครับผมครับ
ครับ เดี๋ยวหาทางก่อน
ได้ครับ
อ๋อเจอละ เดี๋ยวนะ ทำไมเรามีแค่1 2 3 4วะรูม 5เราไม่จะไม่เจอรูม 5
มันไม่อยู่ มันไม่มีอยู่
อ๋อ เอ้ย อ๋อทำไมเราจันเห็นเราเป็น move to เดี๋ยว move ไปรูม 1ก่อนก็ได้
โอเคครับ
Okay, welcome back. So now it's time to work on this problem together. All right, so we have, you need explanation first? No? Do you need explanation? So we work on one company. We have 4 products, okay? So, and we require, wow, we have 2 machines, right? And 2 type of labor. And the amount of in your unit of hour required to make each product are listed in this table, okay? And this is price, unit sale price of product 1, 2, 3, 4, okay? And each month we have some constraint here, information here, 700 hour available for machine 1, 500 hour available on machine 2, and each month the company can purchase up to 600 hour of skill labor, okay, and skill labor. The company wants to determine how much of each product it should be produced, okay? How much we produce product 1, 2, 3, and 4 each month, okay? And how much labor to purchase in order to maximize its profit. We want to maximize profit, right? So look at the decision variables, okay? Sorry that we don't have time to look, wow, for each solution. I mean, solution of from each group. So for decision variables, we have the number of product I to manufacture, right? Xi. Okay, so we have X1, X2, X3, X4, right? We have 4 products, right? And what else do we need? Decision variables on the number of hours of skilled labor. We use YS. And unskilled labor we use YU, okay? We have YS, YU, and X1 to X4, okay? And the objective function is, we write the objective function this way. We know the price of X1, right? No, not X1, product 1. The price of product 2, price of product 3, and product 4, right? And this is the amount of the number of product produced, okay? So we write this way. And what else? What about the cost? Cost is depends on the skilled labor and unskilled labor, okay? This is a skilled labor and unskilled labor, and this is the number of hours we purchase. So what about constraint we have? We have constraint on time on machine 1, right? Machine 1, we know that if we produce product 1 as X1, we need 11 hours. So 11X1 plus 7X2 plus 6X3 plus 5X4. And we have only 7 hours available. So we write this way, okay? Equality constraint. Time on machine 2 also. And skilled labor, okay? What we purchase and what we use to produce product 1, 2, 3, 4, okay? And available skill is labor. We can purchase maximum of 600, right? And for unskilled labor, okay, it must be less than YU, okay? And YU, we can purchase maximum of 650, okay? And all these variable must be non-negative. It can be positive or 0, okay? Okay, so it is done. We write the optimization problem this way. We maximize this objective function by using these variables, okay? And we list all the constraint here, okay? And this is really important. Xi, Ys, Yu must be greater or equal 0, okay? This is non-negative condition, okay? Okay, Then we finish any question first? Any questions? No?
Ajahn, I have
Yes.
actually one question.
Yes.
Is it okay to combine the constraint number 3 and number 4? So we write as 8x1
This
plus
one?
5x. Yes, that one and
No.
the one below.
You will obtain different solution.
Oh,
You will obtain different solution, right? Because if you combine this, that means, well, you purchase the skill labor as 600 each month. You already defined that, okay? But if you formulate this way, well, we can buy less than that, right? Because
okay.
it affects the cost. Okay. All right. So I need feedbacks for our first week. Yes. And what else? What was it? You can look at the course syllabus in the my course view. Okay. But I put this, wow, the contents of this week as a first week, but you see that the first week is actually 2 weeks ago, right? We will try to cover it, yeah, but we will try to make up it, yeah. But at the moment we behind the schedule. It's all right. Okay, good, everyone. Yeah, please, well, put some feedback there, and well, we will see you again next week, but online again. Yeah, I will send you the online link, the Zoom link later. Okay, so the video we record today, we put on, well, in YouTube maybe, and then I will put a link in my course view. Okay, thank you very much, everyone, for your participation. Okay,
Okay, thank you.
have a good day.
Thank you,
Bye
Ajahn.
bye. Bye bye.